We'll now be doing question 10. The function f is defined for x is an element of R. Okay, so this means that x is a real number. Okay, so that symbol you see there is actually written this way, which represents real numbers. Okay, is such that f double prime x, that means the second derivative of f, is given by this expression. Okay, this expression here, second derivative, the line x equals to half is the normal to the curve at the point where y equals to 1/4. Okay, so this sentence here is a very important sentence because it actually provides you quite a lot of information in the question, right? So you have to kind of understand or try to visualize what this means. Okay, what this given information to you mean, because it's going to be useful to you as you solve the question later on. All right, so what is this concept of normal? What does it mean by a normal? And what is this line x equals to half? What does it look like? Okay, you have to be able to visualize it, right? So x equals to half is as you all know, it's a vertical line, right? It's a vertical line that cuts at x equals to half. Okay, so if you have a normal that is a vertical line, what does it tell you about the corresponding tangent at the point x equals to half? Right, so if your normal is a vertical line, x equals to half, then what does it tell you about the tangent at this point? The tangent is always perpendicular to the normal, isn't it? Right? So if this is the normal, then the tangent must be perpendicular to the normal. Okay, which means that this curve at this point where x equals to half is actually a turning point, right? Because the tangent, it's okay, so I'm just going to anyhow draw one lah. Okay, let's say it's this curve. I don't know what it looks like. I have no idea what the function looks like. Okay, but I'm just going to assume there is a turning point like that. Okay, could be a minimum point, a maximum point. It doesn't matter. At this point in time, I'm just trying to visualize what this turning point is, right? So this tells us that at x equals to half, the function is a stationary point. And what happens at the stationary point? The first derivative, or the f prime of x, okay, in this case f prime of half, is equals to 0. Right? That's what we learn about stationary points. At stationary point, the dy dx is 0. Right? So this is what we know about the function now. Okay, the other one that we know also is that the coordinate of this point, although not specifically mentioned, but the coordinate of this point is actually half, comma, 1/4. Right? Because they wrote here at the point where y equals to 1/4. Okay, so written in the function form, I can then write f of half is equals to 1/4. Right? When I sub in the function, when I sub in the x value to be half into the function, it should return me the value 1/4. Okay, so hidden in this sentence is so much information which you should be able to derive as you read the question. Right? Okay, so now we can go into continue and find and solve the question. Part 1, find the expression for f prime x. Right? So what are you given? Okay, always ask yourself, what am I given in a question that can give me f prime x? Right? I'm given f double prime x. Okay, the expression. So in order for me to get f prime x, I will have to reverse it and integrate the expression. So f prime of x is the integral of 48x squared plus 2e to the power of 2x minus 1. Okay, when I integrate this, it's 2 terms, so I can distribute my integral to each of the terms. Okay, and then the constant or the coefficient in front can be pulled out, and then I integrate x squared to give me x cubed over 3. Okay, pull out the constant, the coefficient 2 again, and then integrate the exponential of 2x minus 1. That will be half of e to the power of 2x minus 1. Okay, then I'll add the constant c. Right, if you forgot how to integrate the exponential function, the formula is here. Right. Okay, then we will simplify this expression. 48 divided by 3, that gives me 16x cubed plus 2 times half is just 1. So this becomes 2 to the power of 2x minus 1. Okay, and then because just now I figured this out, right, this information here, that at x equals to half, my function actually has a stationary point, which means that the first derivative is 0 at x equals to half. So that will help me find my c, since f prime of half is equals to 0. When I sub in x is equals to half, I will get 0. And this can help me solve for c. Okay, so this will then be simplified to half to the power of 3 is 8. So this is 2. E to the power of, e to the power of 0, that's 1. So c is just negative 3. So that answers the first question. F prime of x is 16x cubed plus e to the power of 2x minus 1 minus 3. Okay, now moving on to part 2. Part 2 says, hence find an expression for fx. Okay, so now that we have found f prime x, and to find fx easy, we will just integrate the expression for f prime x. Okay, and then there are 3 terms here, so I will apply our integral on all the 3 terms. Okay, actually you can skip this step if you are used to it already. Okay, then from here we will take out the coefficient, power plus 1 divided by our power, integrate, differentiate the power, and then constant becomes x. Okay, then plus c again. Alright, and then over here I can simplify this a little bit. Okay. Alright, and then I have to find c again. Okay, so just now we already understood from that sentence, right, that f of half is 1/4, right? And hidden within the sentence is the coordinate of the point of the function at the point of x equals to half. So since f of half is 1/4, I can then sub in and solve for my c. Okay, and then when you solve for this, you should get c to be 1. Okay? Alright, and then you can get the answer. Therefore, f of x is this is the answer for f of x. Alright. Okay, moving on to part 3. Show that the equation of the tangent to the curve at the point where the curve intersects the y-axis can be written as this. Okay, this expression over here. So what do they want in this question? They are asking for the equation of the tangent. Okay, equation of the tangent where the curve intersects the y-axis. Okay, so how do I find the equation of a tangent? A tangent is a straight line, and I know that the equation of a tangent is given by what concept? Y equals to mx plus c, right? That's the concept that we learn about straight lines. So in order for me to find the equation of a straight line, I will need two things. I will need the gradient and I will need the y-intercept. Correct? So at the point where the curve intersects the y-axis, this means that you already have the y-intercept as long as you sub in x equals to 0. Right? Intersects the y-axis means that x equals to 0. Okay, so that's what we'll do first. We will find the point where the curve intersects the x-axis. Oh dear, I need an extra page. Okay, so part 3. So when the curve intersects x-axis, y-axis, sorry. Y-axis, x equals to 0. So we're going to sub in x to be 0. And this will give us this expression. First term is 0, e to the power of -1, so it's 1 over 2e plus 1. Okay, so this is the point where this is the y coordinate of the point, right? And then we have our gradient. We have to find our gradient. So f prime of 0, because when the curve intersects the y-axis, x is equals to 0. So our expression for f prime x is over here, 16x to the power of 3. So let's write that down. 16x to the power of 3 plus e to the power of 2 times 0 minus 1 minus 3. Okay, and then if I were to simplify this, e to the power of -1 again, so it's 1 over e minus 3. Okay, so I have my gradient. This is my m. This is my gradient, right? And this is my y-intercept, my c. Okay, my y-intercept. So I can now write it into the equation of a straight line, equation of a tangent. Therefore, equation of tangent is y equals to mx plus, sorry, what's going on? C. Okay, so after I write into this, I still have to show that it gives me that the expression that they want, right? So over here, let's remove the brackets first. Okay, and then we all can see that the denominators are all exponential. Okay, and in the expression or the equation that they asked me to write, there's no fractions at all, there's no denominators. So in this case, I'm going to multiply 2e on all the terms. Okay, so multiply 2e on all terms, and that will give us 2ey equals to 2x minus 2 times 3, that's 6ex plus 1 plus 2e. Okay, and then rearranging all the terms, all the 2e terms they want to collect on the left. So all the exponential terms, I'm going to move it to the left side. So this is 2ey plus 6ex minus 2e equals to 2x plus 1. Okay, then I'll factorize out the 2e, which is what the question wants. And this is my answer shown. Right, so that's it for question 10.